with our next experiment, that is energy trap of an in-centric semiconductor. So what is a semiconductor? A semiconductor is a solid material which has the properties between an insulator and a conductor. You know, and what is an insulator? Insulator is a device which, insulator is a material which will not conduct electricity. Your best example is rubber. Yes, but what is a conductor? A conductor is a material which conducts electricity. The best example is copper. Now we are talking about something known as semiconductor. From the word itself you can understand that a semiconductor is a material which has the property between a conductor and insulator, right? Between a conductor and insulator. So where is it going to be a conductor? Where is it going to be an insulator? So at below temperature, at low temperature, this semiconducting material will have the properties as an insulator. Is it clear? So lower temperature, it will behave as an insulator. But as you are increasing the temperature, it will act as a conductor. So that's the reason we are defining as a semiconducting material is a material which have the properties between an insulator and conductor. So now when you take your semiconductors, you have two types of semiconductors. One is in-centric semiconductor, the other one is eccentric semiconductor. So what is in-centric semiconductor? A pure semiconductor is said to be an in-centric semiconductor. And impure semiconductor is said to be an eccentric semiconductor. So what is in-centric? What is the meaning of pure and impure? As I told you that it is going to conduct electricity, right? It is going to conduct electricity. So when it is conducting the electricity, you are going to also increase your efficiency. That means how best you are going to use it, right? How best you are going to use it. So for that, what we do is we take a pure semiconductor, that is in-centric semiconductors, which are pure. They may not have the efficiency properly, right? Suppose if I am taking some semiconductor like germanium and silicon are the examples of semiconductors, right? They are pure semiconductors, but we want some conductivity of germanium or silicon. They are not coming. So what to do? We have to increase the efficiency. So how to increase it? We add some impurities. How to increase the efficiency? By adding the impurities. So adding of impurities is nothing but doping. What is it? Doping. So by doping you get another type of semiconductors, that is eccentric semiconductors or impure semiconductors. So today in our class we are only talking about in-centric semiconductors, that is pure semiconductors. So when you take a pure semiconductor is going to have something known as bands, B-A-N-D, bands. So what are bands? Bands are nothing but when you take a semiconductor, what is a semiconductor? Is it an atom? Yes? Is that material, semiconductor material, is it an atom?
Yes, ma'am.
Yes or no? Yes, it is an atom. So when you take an atom, you have a nucleus in the middle. Around the nucleus you have electrons. So now the electrons will be having energy. Yes or no? Will electrons have energy or no?
Yes, ma'am.
Yes, energy will be there. So now when the energy of an electron are combined together as a group, are you getting? Some of the energy of some of the electrons are combined together. That combination, that combined group is said to be a band. What is a band? A range in which certain electrons will have certain energy. Okay, now all will have. We are talking about in-centric semiconductors where they are going to have some bands. So what are bands? Bands are the places where we are talking about energy possessed by an electron. So when you take the band, we have basically three bands. What are the three bands we have? Inner band, valency band, conduction band. Clear? What are they? Inner band, valency band, conduction conduction band. So what is inner band? Inner band is a band where the electrons are tightly bounded to the nucleus. They do not want to come out. They want to be close to the nucleus. But when you are talking about valency band is a band where you have electrons which are loosely bounded, outermost orbit. The electrons which are there in the outermost orbit. You have studied in your chemistry, right? Yes. So the electrons which are there in the outermost orbit and which are helping us to move from the outer orbit, those electrons are known as valency electrons, and those electrons are going to have energy. That energy, if it is grouped up together, it is known as valency band. Then what happens now? The electrons are free to move up and down, right? So when they are moving up and down, they are going to have, they are going to have, they are moving to some other level, that is conduction level, right? What is that level? Conduction level or conduction band. So that is the band where the electrons will be moving and conducting electricity. As I told you, at the higher temperatures, electrons will conduct electricity, right? So that higher temperature where they are conducting, they are forming a band. That band is said to be a conduction band. But between the conduction band and valency band, there is a small gap. There is a small gap. What is the gap? That gap is known as energy gap. What is that? Energy gap. So why are we having that energy gap? Directly very point to the, it can directly go to the conduction band. But why? Why is it happening? That is happening because at certain time period, at certain temperatures, the electrons are not conducting. So when the electrons do not conduct electricity, when they are in immobility state, they'll ask you what is energy gap. Energy gap is a gap where electrons are in mobility state. They do not have any conduction taking place. So that gap is said to be a energy gap. So now our experiment is, what is the energy gap of a semiconducting material? So for silicon you have a certain energy gap. For germanium you have certain energy gap. Right. You have a formula. Eg is equal to, yes, one of you read the formula. Eg is equal to, what is the formula? Open your book. Eg is equal to, yes, louder.
2.303 into K is rho by 1.6 into 10 power minus 19.
Yes, what is that 1.6 into 10 power minus 19 to lose charge of the electrons? Because we are talking about electrons, angular electrons. Which electrons? Electrons in a pure semiconductor, in-central semiconductor. So we are calculating Eg by taking the slope. So how to calculate the slope? We know that when you take your semiconducting material, generally semiconducting materials can be used as a semiconducting devices. That is, the best example is diode. Yes, so you know what is a diode? Diode is a semiconducting device which has two terminals in which current flows in one direction only. A direction of flow from current to?
One direction.
Only one direction. So what are the terminals it is going to have? It is going to have two terminals. Positive terminal and
Negative terminal.
So when the current is passing through those terminals, what is happening? How are the electrons moving? What is the energy gap between the valency band and conduction band? We are going to calculate with the help of thermal heating of a diode. Right? How are we doing? We are not doing electrically. We are thermally heating it. Can we electrically find out? No. Can you electrically find out what is the energy gap of a diode? Electrically. Can you find the energy gap of a diode electrically? Yes, you can find out. Right? If you connect it to your voltmeter and ammeter and start increasing your voltage, and you will be getting the current, you can calculate and find out. You plot the graph and you will get it. But here we are talking about thermal heating of a diode. What is thermal heating? Heating of a diode. Right, heating of a diode until you can't directly keep it on your stove. Can you keep it on your stove? No. At the same you can't even put it inside your water. Beaker of water. Right, what will happen? If you put it in water, your conductivity will not be there. Right, if you put it on the stove, it will burn away. Yes, so to avoid that, what we do is we take a semiconducting material in the form of a diode and insert it into an oil. Right, so what is oil? Oil is the conducting material which is indirectly heated with the help of beaker of water. If you look at this setup, I have kept a beaker of water in which an oil beaker is placed, inside which a diode is placed. Right, a diode is placed. So what am I doing? I am indirectly heating the oil. Right, can we heat the oil directly?
No.
Why? What will happen? Yeah, as your heat is increasing, your this one, you get your bubbles and you can't put your fingers and all inside that, right? You can't put your fingers inside that. So to avoid that heating, we indirectly heat the oil, right? So this is all about your precautions. This is the precautions to be taken. Never directly heat the oil. Never directly heat your diode. Yes, never directly take out the thermometer. And here we are particularly talking about what is the changes happening for the diode with respective oil. So you have to always dip your thermometer inside the oil, not inside the water. So if you are dipping it inside the water, it is going to show the temperature of water. But what do we want? We want what is the temperature of oil when it is heated. Right? Are you getting it? When it is heated, what is the temperature of oil? Isn't it? Right? Isn't it? So when it is heated, you are going to find out. So if you are looking into your circuit diagram, right? Look into your circuit diagram. Here, when you are going into
Battery
your circuit diagram, always you connect your diode in reverse bias. Right? Why in reverse bias? In
Because
reverse
it's low
bias, you are going
high
to have a high resistance and low current as I am indirectly heating it. I am indirectly heating it. So when I am indirectly heating it, what is happening? Very small amount of current is going to come. Right, very small amount of current is going to come. So because of that, we are connecting it in a reverse bias. Right, they'll ask you in Viva questions, how are they connecting it? They are connecting it in
Reverse bias.
So what is a reverse bias? A positive connected to negative.
Negative connected to positive.
It is said to be a
Reverse bias.
Right, isn't it? So if you look into your circuit diagram, this is an AC, this is a DC circuit, isn't it? It is a DC circuit. So because we need we need to change, we need to have a change in the voltage, we are using an external battery. You may say that, madam, we are heating it. Then directly you can take thermometer temperature versus whatever current you are getting, heat produced and your temperature you can note down. But how is this happening? How is it heated up this diode? It is heated up with the battery. Yes, that too, which type of battery am I using?
Acid battery.
I am using an acid battery. So when you take an acid battery, it is chemically heated. It is not electrically heated. It is chemically heated. So when it is chemically heated, it is going to produce the heat. That heat is again impacted with thermal heat and it is going to increase the temperature. Right, it is going to increase the temperature. So quickly look into your circuit diagram. If you look into your circuit diagram, from the positive of the battery connected to the resistor, right, connected to a resistor. Then from the resistor connected to negative of the diode, right, connected to
Negative of the diode.
Then positive of a diode connected to positive of the ammeter. Then negative of the ammeter connected to negative of the battery. Is it a reverse bias? Yes, it's a reverse bias. Right. Now, why do we need an ammeter? Why do we need an ammeter? To measure the current. Yes, to note down the current. Then to note the current, we have to give the voltage, isn't it? We have to give the voltage. So how will we give the voltage? With the help of voltmeter, right? With the help of voltmeter. So you know one important step that voltmeter should always be connected in parallel. Yes, voltmeter should always be connected in
Parallel.
So I have taken a voltmeter and connected parallel such a way that positive of the voltmeter connected to one end of the resistor and negative of the voltmeter connected to one end of the battery. Isn't it? I'll make this circuit very simple, linear pencil. Yes. Yeah. So look here. Positive or negative of a battery connected to resistor connected to diode negative, then positive of the diode connected to ammeter, positive ammeter, then ammeter negative connected to negative of a battery. Isn't it very simple? Is it simple? Yes, is it simple? Then what I needed, this is a battery, this is a diode with negative and
positive.
Right, this is positive, this is negative a battery. Right, then this is your ammeter. Now voltmeter I'm connecting parallel such a way that positive and negative. Isn't it? The same thing. Okay, fine. Now, when this circuit is connected in the with the help of the components, you are going to measure what is the variation happening. Yes, in the diode, as the temperature is increasing. What is it? As the temperature is increasing, what is the variation? If you look into your tabular form, what do you have? You have your temperature, yes, versus current for certain voltage. Right, for certain voltage. Here you can get even a voltage changing also. You can change your voltage also, but we are not worried about voltage. We are only finding what is the relation between the temperature versus current. That's all. We don't know what is the voltage. For that reason, I set my voltage constant, that is 1.5 volts. Is it clear? Is it clear? Very clear. If you want, you can vary. You can vary the voltage also. But manaki endante with the temperature, how is the current changing ante kavali. We do not want what is the voltage changes happening. So that's the reason we have taken only current and temperature. Is it clear? Shall I connect the circuit? Yes. So look at your connection, look at your circuit diagram. So this is your battery, which is an acid battery, which has a positive terminal and negative terminal. Very, very important precaution. Never connect your battery before you start off your experiment. Make sure that you know the terminals of a battery, but don't connect it. Why you should not connect? Because it is not an electrical battery. Electrical battery means you can directly put your nose and connect it, no issue, as you switch it on it will. But here, because it is a chemical battery, what will happen? The once they are in contact, it starts giving the energy. It starts giving the
Energy.
That should not happen, right? Energy is used before doing the experiment, then what will the energy be after the while doing the experiment? It will not have, right? Yes, so because of that, never connect it. Just identify a positive terminal, negative terminal and keep it. That's all. Okay, now, so this is your battery, this is your diode, yes, incentric diode, which is inserted into an oil, and this is your thermometer. Which liquid is used inside the thermometer? Mercury. Right. So mercury is going to give us the temperature level, rise and drop of the temperature level, and you have a beaker in which it is filled with water under this now, and you have a resistance boxes here, which is going to be used to give certain resistance, right? To give a certain resistance. And this is your ammeter, and that is your voltmeter, right? This is your voltmeter. Listen carefully, girls. Voltmeter we use it between 1 to 10 volts. Voltmeter we use it between 1 to 10 volts, and ammeter we are going to use only in microamperes. I repeat, your current is going to be very low. You already said it, right? And that current is always in the order of microamperes. 1 microampere, how much is 1 micro? 10 power?
Minus 16.
6. Minus 6. 10 power minus 6. So 1 micro is equal to 10 power minus 6. So 1 microammeter is 10 power minus 6 amperes. So always it is an order of microamperes which is you are going to measure, and it is going to be very, very small. Very small. Okay, fine. Is it clear? So we start off the experiment, right? Stop. Actually, to tell, this is the simplest of all the experiments. If you know the circuit diagram, right? If you know the circuit diagram, it is very, very simple experiment. The only thing is you have to know which is the positive you have to connect, which is the negative you have to connect. If you look here, this is my positive terminal and this is my negative terminal, right? So I start off with my positive terminal, right? So as I told you in your precautions, I told you that never start connecting it before experiment. So I just identify and I kept my positive of the resistor. So one of the precaution is when you are using your resistor, make sure that all the keys of the resistor are tightened. Precautions, they cannot be by hearted. You have to understand how to write if you know what are the components used. Right. One of the precaution I can use, the simple precaution is always use the straight wires without any themes. Right. That we need not by heart. By seeing the wire you can understand, isn't it? Some of the girls will say, "Ma'am, I didn't learn my precautions, madam." You need not by heart. You have to only remember the thing, how you are connecting and what you are doing. Isn't it?
Yes, ma'am.
Yeah. So I have tightened all the keys, right? Now, so one end is connected to my resistor, from the other end to the negative of the diode. See those, when you take here the diode, this is a PN junction diode. Yes, this is a PN junction diode. So in a PN junction diode, how to identify it? If you are telling it theoretically, you have a straight line, you have a triangle, you know that straight line is a negative and a triangle is a positive. But here, you will be having a small black part in this. That black part is negative. Yes, that black part is negative. So I take the negative end of the diode. Yes, negative end of the diode and connect it to end of the resistor. Isn't it?
Yes, ma'am.
Is it clear, Sumaya? Yes, ma'am. Yeah.
And next, positive of the diode to ammeter positive or negative.
Yes. Then after this, yes. Now I take my positive. Right, I take my positive. I connect it to ammeter positive. So this is my ammeter positive. Ammeter positive. Ammeter polarities inside. Do it have a polarity? Ammeter?
Positive or negative? Positive.
Yeah, positive. Do it have? Yes. It has the polarity. So I have connected to positive of the ammeter.
And negative of ammeter to
yes.
battery
Then
negative.
negative of a negative of
ammeter
to battery.
Battery negative.
So as you know that you are using your acid battery and using this type of wires. They are very, very important precaution. What type of wires have to be used where? You should know
Straight
that also.
wires.
Yes. So platted wires you are using and you are connecting it here. So what is this connection? So all these connections are in series or parallel?
Series, ma'am.
They are in series. Then we need a voltmeter from 0 to 10 volts. Voltmeter. So I take my voltmeter, I connect it such a way that positive is connected to resistor. Oh no, is it right?
Yes, ma'am.
Yes. Positive is connected to one end of the resistor. Right, I connected here. Resistor, does it have a polarity? Resistor, do it have a polarity? No, it doesn't have a polarity. But make sure that where are you connected? You can't connect both the ends at one place, isn't it? Can you connect it?
No,
if you connect like that, it will be shorted. Right. So make sure that one end, the other end, the other end. Yes. Is it clear? Is it clear? Yes.
Voltmeter negative to
Yeah.
మనం బ్యాటరీ నెగిటివ్ పెట్టడానికి రాదు కదా మామది
ఏది
నేను ఎంతసేపు చెప్పారు కదా బ్యాటరీ నెగిటివ్ అని
బ్యాటరీ నెగిటివ్ రాదు కాబట్టి వాటర్
అమ్మీటర్ నెగిటివ్
ammeter negative కి పెడతాం. Yeah. Because technically you can't keep it, I keep it to ammeter negative. You can keep it. Input a wire if you have it, you can keep it, but
ఇలా
to
ఉంటే
avoid
పెట్టచ్చు కదా మామ ఇలా ఇంకా
like this black wire if you have, you can keep it. So to avoid that, I can directly keep it. Yes. So now put this wire now. Put this wire. Petunda on cherry. So on cherry.
ఇట్స్ ఆన్
Now look at your tabular form. As you look at your tabular form, what is your room temperature? First of all,
30 degrees.
note down your room temperature. Today it is very
24.
what? It is
24
like a
degrees.
very rainy temperature we have, so it will be around
క్లౌడీ
how much
28
now?
27 28
27 degrees centigrade it is, right? So room temperature is 27 degrees centigrade. Okay now? Temperature is. Now switch on the stove and make sure that all your heating part is done very safely. Okay, ma'am.
గంటలకు
Fine. Now, yeah. Now what you do is on ma'am.
చేసాం మ్యామ్
Dale
ఏ
1 minute of battery feeding करना. Lights डाले.
టైట్గా పెట్టు తీసి పెడదారు
Yeah.
పెట్టు
Listen. Now see. Now
ఏ
what you do is you start taking the resistance value 1.5 ohm or 1 ohm. Yes. So how much you are taking now? 1 ohm. Right. Where is 1 ohm? Here is 1 ohm. Right. 1 ohm. Right. 1 ohm you have taken. So now, as you are increasing the temperature, for every 10 degrees, note down your temperature, note down your current value. So, how much was the temperature?
27 degrees.
centigrade. 27 degrees, see how much is your current value. So, 36,
30
how much is your current value? 47, how much? Up to where will you do that? Up to where will you do that?
5 values
Up to higher temperature. Today is very cloudy, right? So you can't go up to 100 boiling point. You can go up to 70. By
70.
50 only your water starts boiling. So whenever you see that there is a boiling or something of water, you stop it and finish it off. And make sure that all your resistor values are
టైట్
tighten. If it is not tighten, you are not going to get your values here. Are you seeing me? Look
Yes.
at this. Yes, are you getting it?
Yes,
Right,
ma'am.
see. Even your voltage, if you can, how much is my voltage? 2. See, I got my voltage at 2 volts now. Whoever hasn't done this experiment, they can start doing it. 2 volts.
మ్యామ్ రెసిస్టెన్స్ ఎంత చేశారు
And the 2 volts will be constant. I have taken 1 ohm. 1 ohm. Voltage is constant, 2 volts. It is showing you the voltage. Come this way. It is showing you 2 volts. Now what to do is start tightening it. You get it. When it is around 37 or so, you get your value here. Yes? So note down your current value. Again after 10 degrees centigrade, note down the value. So after that, you are going to plot the graph between 1/2 versus plot R. So how to find out plot R? First you have to find out R value. What is R? R. What is R?
V by I.
From your own plot,
Voltage by
V
current.
I. So take your value, then plot the graph. When you plot the graph, it is going to be a straight line. Right.
Raising.
Draw slope. You
Triangle.
draw the slope. M is equal to y2 minus y1
by x2 minus x1
And how to find out R value? V by I.
V by I.
When you substitute all that, you are going to get your energy gap of a incentric semiconductor. Your result, your final result is incentric semiconductors, which are silicon and germanium. They are going to have a standard value. That is, if you are taking your silicon Si, 0.7 electron volts. Remember like this. How to remember, madam? Silicon 7. Yes, Si, silicon is 0.7 electron volts. Yes, silicon 1. Yes. So you will be having the standard values for silicon and germanium. That is, I already make you to write it. What are the values? What is it?
Germanium 0.7 electron volts, silicon is
1.1.
Yes, silicon is 1.1 electron volt, germanium is 0.7 electron volt, right? So when you do this, it will be having an experimental error of plus or minus 10. Okay, plus or minus 10, more than that it will not. So in points of larger temperature, you can make it. Okay, you want to do it? So